Hey everybody. So we have one more type of naming that we have to talk about, and there's no great place to put it because honestly, acids are not ionic compounds, but they're also not truly covalent compounds. And you're going to learn more a little bit later on in this unit about how that can be. And maybe you'll see a little bit in this naming section how acids kind of ride the line between ionic and covalent. So we're going to talk about their naming rules here because they do have very distinct rules for naming that are going to be important for us moving forward as we go to write chemical reactions. Also, the definitions for acids get a lot more complicated as your understanding of chemistry gets more in depth. But for now, you can consider acids to be substances that have a hydrogen in the front of the formula. And the hydrogen at the front of the formula is going to behave ionically with a 1+ charge. Why is my handwriting so gigantic? Nobody knows. Now I'm using the color red because acids are substances that when they go into solution, they drop the pH into a pH that is less than 7, 7 being neutral. So these lower pH ranges are acidic. And the universal indicator that we use, as well as the litmus paper that we use, turns red in the presence of an acid. So hopefully this will just sort of drill that into your head. Okay, so acids are substances with hydrogen with a 1+ charge at the front of the formula. So you can see how they kind of are ionic because they're dealing with charges. All right, a binary acid is when you have the hydrogen with the 1+ charge bonded to a singular element, just one element. So for example, hydrogen with a 1+ bonded to chlorine with a 1-, those charges would cancel out and you would have the acid HCl. So we are balancing charges as if these substances were ionic. However, they're a nonmetal to another nonmetal, which makes them kind of covalent. See how they kind of ride the line between the two? More on this later. Let's balance the charges between hydrogen and sulfur. Here we would have the formula H2S. So these are two examples of what we call binary acids. Bi meaning two, hydrogen plus an element that makes two elements in the compound. So how do we write names for binary acids? The naming rule looks like this. We use the prefix hydro, and then we name the element that the hydrogen is bonded to, and then we change the ending to -ic. I really am not happy with my handwriting, you guys. I'm very sorry. I'm going to change the ending to -ic acid. Now, this hydro in the front does not stand for the hydrogen, okay? This hydro in the front is telling us that the acid is a binary acid, okay? So the hydro means that it's binary. It does not mean hydrogen. The fact that it's an acid at all means that there's hydrogen, okay? So don't associate that hydro with hydrogen, associate that hydro with binary. Okay, so let's name these acids. This would be hydro, because it's binary. Name the element, chlorine, but we're going to change the ending to -ic. This is hydrochloric acid. Same thing again. It's a binary acid, so we're going to use the name hydro, and then the element, sulfur, and we're going to add the ending -ic. So sometimes you're like taking the ending and changing it to ic, and other times you're adding the ic. You'll get used to where it goes. So in the case of chlorine, it's a changing to ic. In the case of sulfur, it's the addition of ic. So again, if you had said sulfic acid, not a big deal. Okay, so when you have binary acids, hydro, element, ic, acid. We did not use prefixes because remember, we're balancing charge. And so if we're balancing charge, we don't have to worry about prefixes. Let's look at oxyacids. Now, hopefully you can tell by the oxy in the name that these are going to be hydrogens, because they're acids, bonded to something with oxygen in it. And guess what all had oxygen in them? Your polyatomic ions. Okay, so if you have hydrogen plus a polyatomic ion, you now have what we call an oxyacid. And we do not use hydro in the name, okay? No hydro in the name. Because, remember, hydro means binary. And oxyacids are not going to be binary. They're going to have 3 or more elements in them. So no hydro in these names because they are oxyacids. So how do we name them? You look at the name of the polyatomic ion, okay? So we're going to look at the name of the polyatomic. If the polyatomic ion name ends in 8, you're going to change the acid ending to ic, acid, just like we did up above. If the polyatomic ion ends in ite, you're going to change its ending to us, acid. So let's give this a go. Let's say we have hydrogen. I'm really sorry about my handwriting today, you guys. Just not feeling it. Maybe I waited too late. I did too much gardening, too much mulching. My hands are tired. Hydrogen with a 1 plus. SO4 with a 2 minus. So balance your charges out. H2SO4. How would I name this acid? I'm not going to use hydro because it's not binary. It's not hydrogen and sulfur. It's hydrogen and sulfate. So if the ending is 8, I just go to ic acid. This is sulfuric acid. But what if instead of sulfate, I had sulfite? H2SO3. This would be sulfurous acid. 8 to ic, ite to us. Go off of your polyatomic ion name. And I really wanted you to highlight, I picked these 3 examples for a reason because I wanted to highlight for you hydrosulfuric acid is H2S, hydrogen and sulfur. Sulfuric acid sounds very similar, same ending, but no hydro. That means that you have something bonded to the polyatomic ion with the sulfate in it, with the oxygen in it and the sulfur in it, the 8 version. So that is a very different acid than H2S. And then if you have sulfurous acid, you're talking about the polyatomic ion's ite version, H2SO3. Let's see if you guys can go backwards on a couple of these. What if I gave you the name chloric acid and chlorous acid? Well, first of all, we know that these have hydrogens in them because they're acids. So we have a hydrogen with a 1 plus at the front no matter what. So put that down always. Whether it's a binary acid or an oxyacid, it's got a hydrogen with a 1+ charge in the front. Okay, if the ending is -ic, it comes from the polyatomic ion 8. It came from chlorate. Chlorate is ClO3, 1-. Balance your charges, HClO3. If the acid ending is -us, it came from the polyatomic ion -ite. It came from the chlorite ion, which is ClO2, 1-. Balance your charges, HClO2. Okay? So, binary acids will be hydroelement-ic acid. Balance your charges for your formulas. Oxyacids, you will also balance your charges for your formulas. Hydrogen's in the front, but no hydro in the name. Go off of your polyatomic ion name, 8 to ic and ite to us. Good luck with your acid naming.